So from the previous slide, I'd like to reiterate on the steps in heterogeneous catalytic reactions. So bermaksud heterogeneous catalytic reactions ni reactions that happens at different phases, maybe from fluid into solid, right? So these are the 7 steps that what actually happens when the reactants, whether it is in liquid or in gas form, which is they are in bulk fluid, going through the catalysis phase. So the first one, there will be a mass transfer diffusion of the reactant from the bulk of fluid to the surface of the catalyst pellet. So we call this as external diffusion. So that step number 2 just now, the diffusion happens still of the reactant from the pore mouth through the catalyst surface until it still go into the immediate vicinity of the internal catalytic surface. So we call this as internal diffusion. And then from there, at the internal catalytic surface, there happens adsorption of reactant A onto catalyst surface. So you just have to imagine that catalyst ni dia terlalu banyak dia punya ruang-ruang tu sampai dia betul-betul jumpa the very active sites. So untuk berlakunya adsorption tu maksudnya A tu dia dah terletak dekat atas catalyst surface. So that's the meaning of adsorption. So when the adsorb happen, the reaction happens on the surface. So that whereby the reactant A, for example, we take this example of single reactant now, from A to produce B. Padahal in real life, there shouldn't be any one single reactant je, dia lebih banyak reactants, sometimes 2 reactants, 3 reactants. Tak cerita lagi pasal parallel reactions, multiple reactions and all. Ni kita ambil yang the very layman. Okay, bila reactions dah berlaku on the surface, B start to dissolve, and unreacted A also will dissolve from the surface lah. Okay, it's either unreacted A tu tak absorb pun maybe. Okay, so the term desorption is we refer more to the B products. And then that B products, will diffuse from catalyst surface to interior of the pellet to the pore mouth. So still kita panggil dia desorption of B through internal diffusion. And then bila dia dah lalu dekat situ, there will be mass transfer of products. Sorry, mana dah saya punya into external surface. Okay, external pellet surface. So this is what we call the external diffusion. So there are theoretically the 7 steps. So saya tunjuk balik this figure, in which that this figure in a layman term to show what happened on a catalyst surface. So these 2 layers representing this layer, for example, this layer representing the bulk fluid, and then this layer from bulk fluid into going about going to the pore mouth of the catalyst. And then kat sini dah start lah pore mouth of the catalyst where the reactions akan masuk further on the catalyst surface. So this is the catalyst surface. And then kat sini akan berlaku desorption. And then produk akan keluar balik ke from the layer from the pore mouth into the bulk fluid here. Okay, so kita mengambil example A kepada B. Jadi, the first step A we're going through external diffusion ataupun external mass transfer. Second step akan berlaku internal diffusion. Dia akan melalui dari bulk fluid ke pore mouth of the catalyst tu. Pore mouth maksudnya porosity tu dia pintu masuk porosity tu. Itu maksudnya. Kemudian step number 3 is where the A start to adsorb on the catalyst surface. Adsorb maksudnya A tu dah start nak terletak atas catalyst surface on the active sides of the catalyst surface. And number 4 where the reactions happen, so kita panggil kat sini term dia surface reaction. So bila berlaku reaction, B pun terhasil, B start to dissolve. Okay, dan dia akan melalui porosity of the catalyst and dia start keluar melalui step 6 internal diffusion and then 7 the external diffusion and then it goes out. So simple kan?
Okay, on this slide, look at the figure here. This is the reactant concentration profiles in direction X. In direction X, whereby the fluid is actually to perpendicular Z. So scientists need try to represent lah, even though the flowing is at the Z direction, but it tries to represent the flowing and the concentration profile at the direction of X. But you don't really have to think much over this figure. Saya just sebenarnya nak menunjukkan the term of the concentration sebenarnya. So concentration yang banyak ni, kononnya tinggi, kita panggil dia concentration of reactant in bulk fluid. So dia punya term short form is CAB. So concentration of reactant A in bulk fluid. So kat sinilah area sini bulk fluid. And then when the fluid going near the external of catalyst surface, okay, kat area ni, so kita panggil dia concentration of reactant at external catalyst surface. So bila bulk fluid dia try to going through tempat yang agak sempit, so concentration dia akan drop lah dekat sini, ya. So kita panggil dia concentration of reactant A at external catalyst surface. Dan that concentration of reactant dia akan terus masuk ke dalam pellets of the catalyst, and so meaning that the concentration further drops. Alright. Jadi kita panggil dia CAX, concentration of reactant within the pellet. Okay, as for this figure, this is another view of theory from a scientist to represent what happens actually on the catalyst surface. So ini the view whereby the flowing fluid from here to here pula. And then kat sini adalah catalystnya. Okay, for example, this is represent the catalyst surface. So the flowing fluid of reactant A, for example, on the way dia nak ada yang terus ni, the fluid going from this area, this point to this point to this point, right? There are reactants that actually migrate down and going through the boundary layer ni and pergi ke external surface of the catalyst palette. Kat sini lah juga berlakunya ada step 1, step 2, step 3, step 4, step 5, step 6, step 7. So still sama. Okay, cuma cara dia terangkan tu macam ni. So dia kata reactant A in the bulk fluid migrate through the boundary layer over the pellet at the external surface, and then it further migrate down within the pellet to find surface sites and where the A adsorbs to reacts to form B. Okay, penceritaan dia still sama, cuma dia ada tambah sikit. Berlaku dekat surface reaction ni is R double apostrophe. Kalau dulu kita belajar R equals to K CA, okay? Tapi ini lebih menunjukkan yang kita belajar dulu lebih menyeluruh sebab dia melibatkan design of reactor, what types of reactor. Tapi kat sini dia double apostrophe represent the reactions on the catalyst surface. So whereby the symbol is different. R double apostrophe equals to K double apostrophe. K pun dia menunjukkan rate constant, rate constant that happens on the catalyst surface, and the concentration of reactant on the catalyst surface, on the surface. Okay. So kita akan tengok this reaction rate on the catalyst surface dekat subtopik yang akan datang.